All right. So in example one, determine if y is a function of x. In this example, there's two parts. Part A, you're given 3x plus 7y equals 9. The second example, you have 2x squared minus y squared is equal to 4. Essentially, when you're trying to solve or trying to determine if y is a function of x algebraically, you try to rewrite y by itself first, right? And then you will examine that equation, okay? If you look at 3x plus 7y equals 9, you can first rewrite this by subtracting 3x on both sides, right? So if I take the given equation, subtract 3x on both sides, then the 3x on the left would cancel. You get 7y equals negative 3x plus 9. This allows us to isolate the variable y by itself, but it's not just y, but it's 7y, right? So I have to move the 7 over to the other side. So to move the 7 over to the other side of the equation, I divide by 7 both sides. Namely, on that right-hand side of the equation, I can divide every single term by 7, okay? So in this equation, the 7s will cancel. On the left, you'll get y equals negative 3 over 7 times the value of x plus 9 over 7. Now, when you look at this equation, when we rewrote the original equation in terms of y is now isolated by itself here. What type of equation does this look like? Well, it looks like the slope-intercept, right? It looks like an equation of a line. So in this problem, this first equation, this is a linear equation. And we know that with the linear equation in this format, it looks like y equals mx plus b, where m is your slope and b is your y-intercept. Now, what do we know about linear equations? Namely, its graph. What does this graph look like? Look like a straight line. Now, without going too much into details here about the straight line, like in terms of point plotting technique, just using our property of slope and y-intercept here, you have a negative slope because the value of x, the coefficient of x, is negative 3 over 7. That means that the line is decreasing. Negative slope implies that the line is decreasing. Now, your y-intercept is 9 over 7. That's where the graph would cross the y-axis. So if this is 0, let's say here's 1, here's 2, then 9 over 7 should be between 1 and 2, okay? Should be somewhere around here. And then I could just draw a line, straight line, that's decreasing. So why did I draw this graph? It's just to depict or show you that this linear equation is going to be a function. Why? Because graphically, it passes something called the horizontal line test. If I drew this horizontal line, let's say, notice that the horizontal lines intersects with the graph at exactly how many points? At 1 point. So, no, well, each horizontal line, right? Each horizontal line just touches the linear equation at exactly 1 point. So it passes the vertical line test. So this linear equation, y equals negative 3 over 7, x plus 9 over 7, it is going to be a function because it passes the vertical line test. But what I wanted to emphasize here is that all linear equations are functions. There are common equations in two variables that you'll see in this class, pre-calculus, that are all functions. Equations like y equals mx plus b that you just saw, y equals x squared, y equals the square root of x, the y equals x cubed. Square root of x, we just got to be careful with because this is only true for when x is greater or equal to 0. Remember, you can't evaluate square root of negative numbers because they're imaginary. It's not part of the real number system. But these are just common examples. Y equals the absolute value of x that are all functions. They're all functions. Okay, they will all essentially pass the vertical line test. So algebraically, if you can write it as y equals something, then you definitely have a function. Okay, sounds good. Let's look at the second example. So in the first example here, we saw that it was yes, it's true. For the second example, give me 1 sec. Let me just move this over. Did I move it here? There we go. In our second example, it was given as 2x squared minus y squared equals 4. So we have to isolate the y by itself. So the first thing that you would do is subtract 2x squared on both sides, right? Subtract 2x squared both sides. The 2x squares will cancel. This gives you negative y squared is equal to negative 2x squared plus 4. And now you would divide by negative 1, okay? Just like how we have the coefficient of 7y in the previous example, you need to divide by 7. Now you divide by negative 1 to isolate the variable y, right? With a coefficient of 1. All right, so we divide these terms by negative 1. This gives us y squared is equal to negative 2x squared over negative 2 is positive. So it's 2x squared minus 4. Now here's the interesting part. We need to get y by itself, but we have a square. How do we get rid of this square algebraically? Very good. You take the square root. Now, when you take the square root of y squared, the square root and the square will cancel out. But you just got to be careful on the right-hand side of the equation. You see, I'm going to write it out for us. Here we're going to get y equals, we just can't say the square root of 2x squared minus 4. This will now just be plus or minus the square root of 2x squared minus 4. Now this changes the ball game for us now, that plus or minus. The plus and minus changes the ball game because every time I plug in the value of x, how many values of y will we essentially get? Say it louder. You're going to get 2 values for the most part, right? Like for example, if you make x equals 3, what's 3 squared? 9, right? 9 times 2, 18. 18 minus 4, 14. Now, 14 is not a perfect square, but you'll get something like the square root of 14, but plus or minus square root of 14. That implies that you have 2 solutions for one. You have 2 values for y for every x value, right? So here we can see that y, in this example, is not a function of x. The reasoning now, let me just erase this equation stuff. The reasoning as to y, right? So we're writing out the reason. We can say that for every value of x, there will be 2 values for y, which violates the definition. So definition, I abbreviate as DEFN, definition of a function. A function states 3 things. 1, you have a set that's essentially called your inputs. You have a set that are called your outputs. The third thing that makes a function click is that there's a rule that assigns exactly 1 input value to 1 output value, right? If you remember functions, you can learn it as like a machine, like a printing machine. Let's say here's a sort of like my machinery. You have your inputs, x, you apply some rule, we call it f, and it spits out y. So for every x value that you plug into this machinery and you apply rule f, it spits out exactly 1 value of y. That's what makes a function click. If you have an x value that spits out more than 1 y value, then you no longer have a function. All right.